Hello, this is Mr. Knowles, and this lesson focuses on reviewing what we've been learning in geometry class and math. And what we're going to do with this lesson is actually draw some different geometric figures on a grid. And we've been going over this in class, so this is just to reinforce what we've been doing. So let's get started. First problem here is draw a rectangle that has four congruent sides with an area of 64 units. Alright, well, let's focus on some keywords here. Thing is, we got to draw a rectangle and it has four congruent sides. So I'm going to kind of sketch that on the side. I know rectangles look like this, but that one I just sketched, that does not have four congruent sides because we know that congruent means equal to or the same. So what we have to do is draw a rectangle that looks like that, which is actually a square. So that's what we're after. And now I have to think of something multiplied by itself equals 64. And I know that 8 times 8 would get me 64. So that's what I need to do. Alright, so let's do that. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Alright. And I'd like you to label your dimensions. So that's a rectangle. All four sides are congruent. And the area inside is 64. Let's go on to the next problem. Draw a parallelogram that is not a rectangle with an area of 24 units. So what I would recommend is on the side, try to think of what a parallelogram looks like first. Just sketch a couple. They look like a rectangle that's kind of lopsided. And now I have to think of the area of a parallelogram. Well, really, what we've been doing in class is visualizing these things as rectangles. And just kind of trying to visualize that and cutting out these pieces that are on the right side here, if we could, and then moving them over here and adding them there to make a rectangle because we know how to find the area of rectangles, and then moving that over there. So what I might advise you at home or in class is sketch out an area of a rectangle first, then draw it a little lopsided, then you'll have a parallelogram. So I need the area to be a total of 24. And I know that 6 times 4 is 24. So I'm going to start out sketching first a rectangle and then making it into a parallelogram. So 1, 2, 3, 4, 5, 6. I'm going to put a line here. 1, 2, 3, 4. This is 6. This is 4. So I'm just going to imagine that there is an imaginary rectangle right here. That's an area of 24. But remember, we want a parallelogram that's not a rectangle. So I'm just going to draw it a little lopsided. Now I do that is I'm going to put a dot here. That's going to be one of the corners. And up above, I'm just going to shift it over 2 spots and then put my corner here. And then connect it like that. And at the top, the length of the top up here, that has to be 6, just like below. They have to be equal in length. So I need it to be 2 more longer. Because I cut this piece off over here on the left, I have to add 2 over there on the right. So it's the same length as the bottom. So I need it to be 6. 1, 2, 3, 4, 5, 6. So my other corner is going to go right there. And the top is 6. And then down below, 1, 2, 3, 4, 5, 6. My last fourth and fourth corners right there. And now I just connect them like that. And the inside of that parallelogram has an area of 24 units squared. All right, next. Draw a right triangle that has an area of 30. So again, on the side, I'm just going to sketch some right triangles just so I know what they are. And the key thing is with a right triangle is you have one angle in the triangle that's 90 degrees. That's 90. That's 90 degrees. That's 90 degrees. That's the definition of a right triangle. And we also learned in class that triangles have an area half of a rectangle. So if I could imagine all those triangles I just drew and sketched here, they're really inside an imaginary rectangle. So if I can find the area of the imaginary rectangle that they're inside of, and then just cut that area in half, I will have the area of the triangle. So all I really need to do is kind of sketch a rectangle and then just cut it in half. So I have 30 units. So a lot of things equal 30. 3 times 10, 5 times 6, 15 times 2. Well, I'm going to use 5 times 6. So let's get started here. 1, 2, 3, 4, 5, 6. That has a length of 6, or a base of 6. And 1, 2, 3, 4, 5. It's got a height of 5, like that. Now imagine there's a rectangle here, and that rectangle would have an area of 30. But if I cut it in half, it'd have an area of 15. Okay, now I have a problem. Because if I cut 30 in half, I have 15. So I need to make this bigger. So we got to think about this a little more. Erase that. So my thought wasn't good, was it? Instead of cutting 30 in half, I actually have to double my dimensions to get 60. The rectangle it's inside of has an area of 60. I hope you're following along. Then cutting 60 in half would get me 30. So these aren't going to work. I need something bigger. Well, 60, I could have 15 times 4, 10 times 6. So let's use 10 times 6. let's try that again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6. 6, 10. The imaginary rectangle is here, and that would be 60, but we're going to cut it in half. We're actually going to do this, and now the area inside equals 30 because we cut that in half, and it's a right triangle. We've got two more to do. Draw an isosceles triangle with an area of 32. Remember, isosceles triangles look like that. Well, that's going to be tricky. Well, let's think of the rectangle it's going to be in. If the triangle is 32, then the rectangle that it's inside has to be twice as big, 64. Okay, so I know 8 times 8 is 64. Let's make a rectangle that's 8 by 8 and try to get an isosceles triangle out of it. 1, 2, 3, 4, 5, 6, 7, 8. That's 8. 1, 2, 3, 4, 5, 6, 7, 8. That's 8. So this is a rectangle with an area of 64, and now I'm going to try to make an isosceles triangle inside of it with an area of 32. Isosceles means that two sides are the same. I'll show you a little trick. If I go to the halfway point at the top, that's going to be my peak of my triangle, because there will be an even amount of squares on each side as far as the dimensions. And then down below, the other corners of my triangle are going to be right there. So it's going to be nice and even on both sides. Two sides are the same, and then I can do that. So that green area creates my triangle, and this side and this side are the same length. So two sides the same length means it's isosceles, and the area is 32 units squared, because it's half of the area of the rectangle that it's inside of. One more. Draw a scalene triangle with an area of 50 units. Alright, so let's think of the rectangle that it could be inside of. And the rectangle that we're going to start with needs to have an area of 100 units, twice as big. And I'm going to use 10 by 5, but there are other ways to get 100. There's 10 times 10. There's 20 times 5. I think my grid's not big enough for 20 times 5. But I'm going to use this one, and you'll see why in a minute. So let's do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 10 by 5. 1, 2, 3, 4, 5. So this is my rectangle that I'm going to use to create my triangle. Scaling means all the sides are different lengths, so I don't want it to be even. Well, this will be the base of my triangle here, that 10. And now I just need to find a place to put the peak that's just not even. So instead of finding the dead center of, like how we did the isosceles, we would pick that point. we're just going to move it over, shift it a little bit. I'm going to shift it over to the right, right there. That's going to be my peak. And now I'm going to connect these, and all three sides are different lengths. And the area inside now becomes 50. Actually, it doesn't become 50. It becomes 25. Do you guys see why? Because the height is only 5. I need the height to be 10 to cut that in half. So let's just change that a little bit. Pretty tricky, isn't it? I think you guys will see why in a minute. Because this is only 5. When I cut that 5 times 10, 50 in half, it's 25. So I need to go another 5 up there. I have to double that. 1, 2, 3, 4, 5. Needs to be inside this rectangle. I'm going to keep that base 10 at the bottom. Using the same idea, I'm just going to put my peak off-centered. I think I'll put it right there. And I'm going to do this again. It's going to look a little weird. I don't have a ruler, otherwise these lines would be straight. I hope that you use a ruler. Alright. So now the area is 50 units squared. Because it has a base of 10, it has a height of 10, but it's a triangle, so it'd be half of that. So the area of that triangle and its scaling is 50 units. I hope you're able to get through this okay. This should help you with the worksheet that you'll get in class. If you need help, please ask.